All right, so let's get started into questions 22 and onwards. Sorry about the delay. I had just gotten home. It's the pie shirt, by the way. Anyhow, on the axis below, graph the function, this guy labeling all important features. So first thing, I always want to start by doing what is the most default version of the function itself? Y equals to 2x plus 1. It is going to be something that looks a little bit, whoops, something that looks a little bit like this. Because something like that. Something like that. Yeah, that's more like it. Yeah. And now just need to keep going like that. Now, at this point, if I were to apply the absolute value, all that does to my graph is that whatever is negative will just be erased. Rather than erased, it will just be bounced off, like such. Wait a minute. That's a terrible drawing. Yeah, there you go. Something like that. Now, and then I apply the -3 afterwards. So it becomes lower by 3 units. Now, here's the problem. Before I do any of these applications or any of the movements, I need to think about what the intercepts are. Right now, the y-intercept is 1 because that's what the y-intercept of just 2x plus 1 would have been. And then the x-intercept would have been -1 and 2 because that's the solution of 2x plus 1. And then once I do the movement, everything goes down by 3 units. So now it goes like this. Boom. Now, what happens to my y-intercept then? It becomes -2. And now, what once was my x-intercept becomes -0.5, comma, -3. That's my vertex. Now, for these two x-intercepts, you can probably see it if you draw it to scale, but you want to also solve it. Yeah. So what are the values of x? Notice how this is the normal positive version of the 2x plus 1, yeah, and the -3. So all I need to do is just assume the positive case. Positive. So now it becomes 2x plus 1 -3, and now I'm solving for that to equal to 0. So 2x minus 2 equals to 0, x equals to 1, which according to the scale, is just true. And what about this negative version? I have the negative one, so I just do 2x minus 1, and then I do the -3, and then equals to 1 is 0. So -2x equals to 4, x equals to -2, which also we can tell from the scale, but sometimes the graph might not give you the scale. Hence, or otherwise, solve for this to be less than or equal to 0. We're looking for the values of x where the function is less than or equal to 0. That is these guys. Yeah, this is where that's happening. Now, this just means x has to be an element of -2 to 1, inclusive. Now, which of the following is true for 5 cos 2 pi x on 3 plus 1? It's pretty straightforward right now. The amplitude is 5, whatever multiplies the sine of cos. So it cannot be these guys because clearly these are the only two that have the 5. Period. Notice how these two are already different. That means we should already be able to tell from the period alone. Period is always 2 pi divided by b when b is whatever is multiplying x. In this case, you can see it's just 2 pi over 3. If you're a little bit confused about this, you can check in your calculator, but you should be able to do this in your head. It's the same as this, which is just the same as times by 3 on 2 pi, which is KFC, cancel, cancel, which is 3. Boom. So it's option D. Worst case worst, sometimes they might not have done that. They might not have given you the periods to be separate. Then you will know +1 elevates every value by 5, and then the amplitude of 5 will elevate go up by 5 or go down by 5. So it should have been 6 to -4. Okay. The graph of x, y equals to ln x is transformed and becomes ln 1 over x. Describe the transformation. What? We have never done reciprocal input before. We have never done that. We have done 1 over x as a graph alone, but that's pretty okay. We have never done this. What is easy is we can just try to apply whatever log rule, we know 1 over x can be represented as x to the power of negative 1. What we do know about the log and their powers is that we can bring them out as a coefficient. So now we have negative 1 ln x. Wait a minute, what do we realize? This is just negative times ln x. What does that mean? Reflection along the x-axis is my y's are being multiplied, so it goes this way. Yeah. Now, question 25 is a bit of a tricky one, and a lot of you guys were on this, and a lot of you guys were a bit unsure about this guy. Let's pick random numbers as A and B. When question's a bit tricky, just pick a number, choose it. It makes sense for you if you do. Imagine if this is 1 and 10, because I know I've made a lot of silly jokes before about 6 and 7. I won't do that anymore. Imagine if I have x equals to 1 and then 9. Let's see, you know what? Let's if I have x equals to 1 and 9, and these are my two values, my reciprocal function, which is 1 over x, will look a bit like this. It's going to be 1 over 1, which means my y value is going to be 1, and then it's going to be at 1 over 9. 1 over 9, because if x is 9, then y is 1 over x. And my domain is restricted from 1 to 9. This means my function can only go from here to here. Oh my God, what? My function can only go from here to here. Now, what does that mean? My y values are restricted from 1 to 1 over 9. Maybe I should have chosen a different number. 1 makes it too vague. 1 over 2 and 1 over 2. So now what do we realize? The small number for a reciprocal function becomes my higher y value. My bigger number becomes the smaller y value because it's a reciprocal. That's what it does. It goes 1 over the x value. So that means big number goes into the lower domain and small number goes into the bigger domain. And what do we realize? A can be inclusive. So we choose 1 over A and 1 over B. Solve this equation. So now you have 2x minus 1 over x. Psych, there should be a log base of 4. And equals to negative 1. Now, at this point, if you don't know how to solve it, then that's no good. You should be able to BAP it. 4 to the power of negative 1 equals to 2x minus 1 on x. Now, this just means x on 4 equals to 2x minus 1, and 1 equals to, what's 2 minus 1 quarter? 7x on 4, x equals to 4 on 7. Okay? Now solve that, correct the two decimal places. This is an ugly number, so hopefully it looks right all right. If I were to get 3 sec theta equals to negative 4, that means sec theta equals to negative 4 on 3. This is the same as saying cos theta equals to negative 3 on 4 because they're reciprocals, right? Sec is just 1 over cos, which means we just flip the fractions. Now, at this point, we think to ourselves, oh, these are two quadrants. It's going from 0 to 2 pi. That's normal, and it's negative, so I know it's going to be these two angles. But I need to find the related acute angle first. Remember, you guys make this mistake a lot. If you guys have a negative, just make up an arbitrary random angle numeral, so it becomes just 3 on 4. Related acute angle. Okay, so now alpha becomes cos inverse of 3 on 4. It should be in radians, so you just solve it. Cos inverse of 3 on 4 is 0. Why did you just do that? 0.7323, sorry, 23. And now when I get rid of it, it goes into present. Oh, that's pretty cool. Anyhow, and because I know these are the related, this is the related acute angle I need, theta equals to pi minus alpha and pi plus alpha, the related acute angle. So pi minus 0.723 and pi plus 0.723. You just have a go. Pi, oops, pi minus answer. The answer is apparently 52, according to my calc. 0 point, what am I doing? 0.723, 2.419. Oh, actually, it is two decimal places, 42, and plus 0.723, 3.86. 3.86. And those are my two answers. When the answers are a bit ugly and it's not a nice number, that's okay. It just becomes decimals. Make sure to keep everything as radians, okay? Now find the equation of the tangent in simplest form to the curve this guy at 1, -1, and 1 over e. Thankfully, they gave us the coordinates, so we don't have to sub back in to find y. That's all good. Now, first thing first, we need y minus y1 equals to m times x minus x1. This is dy on dx at x equals to 1, and we have x equals to 1 and y equals to 1 over e. So we got to differentiate first, right? dy on dx equals to 2x e to the power of negative x plus and minus x squared e to the power of negative x. I'm not going to really show the product rule anymore. You should be able to do this. At x equals to 1, dy dx equals to 2 times 1 times e to the power of negative 1 minus 1 e to the power of negative 1, which is just 2 over e minus 1 over e, which is just 1 over e. Nice. Therefore, gradient is 1 over e. You just chuck it into your formula. 1 y minus 1 over e equals to 1 over e bracket e x minus 1, y equals to 1 over e x minus 1 over e plus 1 over e. Cancel, cancel. Y equals to 1 over e x, or x over e, whatever you prefer is fine. Now, point P on the graph, y equals to g of x has coordinates negative 6 and 3. Find the coordinates of the image of the point on the graph, y equals to that. Now, all we just really have to worry about is it just becomes, sorry, if you're a bit confused about it, we can take it one step at a time. So we can just factor it out. I'm just taking it really formally right now. There's a dilation first, and then there's a translation by 3 on 2. So what we can do is we just first start by doing the dilation of 2, which becomes negative 3, comma 3. And then we do the movement of right by 3 on 2. So it becomes negative, oops, negative 3 on 2 now. And then comma 3. And then you minus the 4. So it becomes negative 3 on 2 minus 1. And that's the answer. Now, if you wish you didn't have to do that, then you could have done just move by 3 to the right first and then divide by 2 for the x value, and then minus the 4 on the y. Or whichever one you prefer is fine. Okay. Now, this is a bit of an extreme version of the question. Now I have cos 3 bracket x plus pi on. If you can't think about it, it's like 3 times what gives me pi on 2, pi on 6. And I'm going from 0 to pi. First of all, period is 2 pi on 3, but I'm going to 0 to pi. It is a bit of a bad one. Oh my, should have probably thought it myself before I gave it to you guys. I'm going to 0 to pi, but my period is at 2 pi on 3. So that means that pi on 3, it's going to be the minimum. So, and now, okay, screw you. this. And then now all we need to figure out is what happens from 2 pi on 3 to pi. Well, what do we know? 0 to pi on 3, it traveled half the way, right? So all we need to do is just go down halfway. Okay. Now, label all the important features. So that probably means find our x-intercepts as well. And then the y-intercept, -1. Now, it always makes it a quarter way through. It always makes the x-intercept a quarter way through the whole thing. This means whatever 2 pi on 3 is, just divide by 4, or halfway of pi on 3, which is just pi on 6. Same thing here, just in between. Um, what's that? My brain is not working. Am I stupid? Why is my brain not working? What? Yeah, you guys should be able to do it. Anyhow, hence or otherwise, solve for this equals to -1. Oh, I didn't realize the -1 there. My bad. So everything just goes down. Zero, 0, -1, and -2. Now, at this point, it makes it easier for us. We don't have to worry about the x-intercept anymore. We just have to worry about when it comes back to start. 0 and then 2 pi on 3. So those are my x-intercepts. So all is well. They don't have to, we don't really care about the rest. Okay. And pi. Now, what we're doing is hence or otherwise, solve for this to equal to -1. Oh, you can go two ways about it. You realize I know how to solve. I have the graph of -1, whatever, but then there's already a -1, right? But I just need to do a -1 again. So what does that mean? I have cos of 3x plus pi on 2 -1 equals to -2. This equation is equivalent to this. All I did was I just -1 on both sides, simply because I already have the graph of this guy. When does this graph touch -2? Well, what do I know? Right here at pi, and right here halfway through, which is pi on 3. So x equals to pi on 3 and pi. If you wanted to solve it algebraically, you could, but it's a bit of a painful one, isn't it? Yeah. Now, initial temperature of the oil is just when T equals to 0. Many of you guys were good at it, so I'm happy. Capital T equals to 50 plus 160, which is 210 degrees. Ricky's cooking, it's my brother's name, is cooking, and at that time, the temperature is cooling at a rate of 10 degrees per minute. Calculate the temperature of the oil at the time. Make sure you read this quite well. It is cooling. Temperature is going down. dt over dt equals to -10. So find out dt over dt first. 0.1 times 160 is -16 e to the power of -0.1 t. Now, at t, oh, we're trying to find t, hey. Okay. Well, we're trying to see -10 equals to -16 e to the power of -0.1 t. So e to the power of -0.1 t equals to 5 over 8. That means we can BAP it. ln 5 on 8 equals to -0.1 t. T equals to ln 5 over 8 over -0.1. And whatever that is, let's see. ln 5 over 8 and -0.1. It is 4.7. 4.7 minutes. Minutes. Okay. What temperature does the oil eventually cool to? What the hell does eventually mean? If I've taught you before, you would know. Eventually just means just after a long time. After time, well, approximately approaches infinity or something. So what does that mean? Temperature is 50 plus 160 e to the power of negative 0.1 T. Well, this is the same as saying 50 plus 160 over e to the power of 0.1 T, right? It's because that's what the reciprocal does. It's what a fraction does. What happens if t approaches infinity? This means 50 plus 160 over e to the power of infinity. What's a number divided by a really big number? It approaches just 50 because this whole thing just turns to zero pretty much. So its eventual ultimate temperature it reaches is 50 degrees. Yeah, I'm really not bothered. Well, interval notation. X can be anything but 2. X can be negative infinity to 2, but not inclusive. Union 2 to infinity. Sketch the function showing all important key features. You might make a bit of a mistake here. This is the same as saying negative 3 over x minus 2. That's the way I like to look at it. Or if some of you guys thought it's the negative of the flip of the x, well, that's the same thing actually. If you're to flip a hyperbola vertically or horizontally, it will just change this way. They're all the same. Anyhow, so what do we know? It is a translation by 2 to the right, and then vertical flip by 1, and then it goes up by 1. Okay? Do, 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 do. Do, 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 do. Bum, ba, bum, bum, ba, ba, bum, ba, ba, bum, ba, da. And then it would have gone like this, right? But then it flips and then it goes up by 1. So now I need to do my asymptotes accurately. What have I done to my axis? Y equals to 1. And now it goes, what should we call it, that way. And it goes this way. Ideally, I would have found my x-intercepts and y-intercepts first, but I guess I was being lazy. Now, I have y equals to negative. Oh, I actually don't have to worry about the negative outside in this case. It's just solve it. Plus 1, plus 1. Yep. The y-intercept is when x equals to 0, which is 3 on 2 plus 1, which is 5 on 2. I am just not myself right now. I am really tired. I don't know if you can see. My eyes are like really dead. It's really exhausted. X-intercept is when y equals to 0. So you have 3 on x minus 2 equals to 1. X equals to 5. I'm skipping a little bit of steps here, assuming you guys can do the algebra. If f of x is translated to the left by 4 units and then dilated vertically by a factor of 6, what is the equation of the final graph? Now, let's think about it like this, right? I like to just keep the separated version now. And then it is translated by 4 units left. So that means I'm going to do plus 4. And then it's vertically dilated by a factor of 6. That means the whole thing just gets multiplied by 6. Now, what does that mean? Y equals to 6 times, that wasn't that funny, plus 1, which is the same as negative 18 over x plus 2 plus 6. Oh, I didn't give you a lot of space for this one, did I? Now this is a comprehension question. Algebra itself is pretty okay. The length of the daylight, LT, is defined by the number of hours from sunrise to sunset. It can be modeled by the equation this. This is the length of daylight. T is the number of days after 21st of December 2015. That's my birthday. Not 2015 though. I'm not that young. Find the length of daylight on 21st of December. No, look at that. I'm looking for L of T at 21st of December. What does that mean? T is the number of days after 21st of December. At T equals to 0. L of 0 equals to 12 plus 2 cos of 0. If you need to check it in your calc, that's fine. Cos of 0 is always 1. So it's just 12 plus 2, which is just 14 hours. Indeed. And now, what is the shortest length of daylight? What does that mean? Minimum. We're looking for the lowest value of this function, which is just 12 minus 2, because cos can be negative 1. 10 hours. You do not need to show working out for this one, I swear to God. What are the two values of t for which the length of daylight is 11? I probably should have given you more space. I'm sorry, guys. I'm looking for 11 equals to 12 plus 2 cos 2 pi t on 366. Now, before you solve this equation, you need to be careful. T is given from 0 to 366, but my T is manipulated. It's gotten messed up. It's something's gone wrong, right? So now all I need to do is just apply what's happened to T1 at a time. T over 366, which means the 366 on the right becomes 1. And then you do the 2 pi, 0 to 2 pi T over 366 becomes 2 pi. So what does that mean? My equation actually just happens from 0 to 2 pi. They just made it really fancy and complicated. All of my solutions will happen from 0 to 2 pi. It's just one normal revolution. And you solve it. Uh, I skipped a bit of the algebra. I'm going to skip it because I don't have space. I should have given you more space. 366 equals to negative half. Now this means 2 pi t over 366 is pi on 6, pi on 3, but second and third quadrants, which is just 2 pi on 3, and then what should we call it? What's the fourth one? 4 pi on 3. Okay, now t equals to 122 and 122, 244. I don't know. If I'm being honest, I can't do that maths in my head. You guys probably would have gotten the right answer, so I'm not going to care about it. Now, carbon-14 is a radioactive substance that decays over time. The amount of carbon-14 present in the kangaroo bone is given by this. This is the whole C. A and K are constants, and T is the number of years since the kangaroo died. Show that C of T satisfies dC on dt equals to Kc. Well, let's see. dC on dt equals to, well, K is just a constant, right? So we just times the K, A e to the power of KT. What do you notice? This is just C. Do you see? K times C. And we've shown question I. Now, after 5,730 years, half of the original amount of carbon-14 is present. What is going on? What they're telling me is that the T equals to 5730, and the original amount is only half there. So instead of A, I have A on 2. C equals to A on 2. So now, I'm just going to equate that. A on 2 equals to whatever the equation already was, A e to the power of K times 5730. A's cancel out. It becomes half equals to e to the power of 5730K. Now it becomes ln 1 on 2 equals to 5730K. If I BAP it, K equals to ln 1 on 2 over 5730. You should probably get negative 0.00012. I'm not even going to bother checking into the calculator. Now, the amount of carbon-14 now present in a kangaroo bone is 90% of the original amount. Whoa, 90%. What does that mean? I have 0.9A. Okay? And then I'm looking for the number of years. So I have 0.9A. That equals to A e to the power of negative 0.000012t. A's cancel out again. 0.9 equals to e to the power of negative 0.100012t. So you just do ln. At some point, you actually become fluent enough. You don't really need to write it out. I'm stupid. Clearly, I need to write it out. And then now it becomes, give me 1 sec. I need to type it up. ln 0.9 all divided by negative 0.00012. 878 years. 880 years because the question says two significant figures. Okay? How good? I'm done. I'm tired. Have a good weekend. Study hard.